Hi, this is Srimitra, Siddharth Institute of Science and Technology. In this video, we will discuss the topic of multiple integration. First, we will start the topic of multiple integration. We start with basic definition, definite and improper integrals. The definite integration is an integral that is calculated between two specific limits is called the definite integrals. It is expressed in the form integral a to b f of x dx. If the integration of f of x is capital F of x, by applying the limits, it is f of b minus f of a. This expression is known as integral, definite integral of the function small f of x between the lower limits x equal to a and upper limit x equal to b, and f x is called integrand. And next one is improper integral. By considering the integration, definite integral a to b f of x dx says that if the limits are unbounded, that is, the given function is unbounded, then the integration is improper integral. For example, if the lower limit may be minus infinity or the upper limit b is infinity, or both, it is called the improper integral. That means simply it is but the function is unbounded, then that integration is called improper integral. The integrals corresponding to first and second are called improper integrals of the first and second kinds respectively. Integrals which satisfy both the conditions 1 and 2 are called improper integrals of third kind. That is, one means either lower limit is infinite or upper limit is infinite. That is first and second conditions. If both the conditions satisfy, then it is called the third kind improper integral. These are the examples: 0 to infinity dx by 1 plus x power 4 and minus infinity plus infinity dx by 1 plus x square are improper integrals of first kind. Next, the multiple integration. The first type of multiple integral is double integration. The double integral for the rectangle R is defined as: let f be a continuous function on closed rectangle R. The unique number I, that is integral, that satisfies the inequality LP of the lower limit and upper limit for all the partitions P of R is called double integral of f over R. And the notation for this double integration is, this is the symbolic representation to integrals. That is, double integration is read as double integration over R f of x comma y with two variables x and y dx dy. It is representation of double integration. So it is read as double integral over R f of x y dx dy. And it is a graphical representation for a double integration value. So this is the region, and the boundary line is denoted this blue line. It is a boundary of the some region. In the region, if you calculate the double integration for the function f of xy, you get the area occupied by the region occupied by the boundary R. This is double integration. So by using double integration, you can calculate the area occupied by, bounded by some curve R. So it is a double integration. To calculate double integration, we can change the order of integration also. That means if we integrate with respect to x and with respect to y, the order means if we integrate with respect to x first and second with respect to y, that is one order, and reversely, that is first with respect to y and the second with respect to x. We can integrate the function in any manner. If the given order is first with respect to y and the second with respect to x, then we can change the order by changing the limits, corresponding limits. To change the order of the integration, we must follow some points. That is, first we sketch the region of integration where we are integrating. So first graphical representation is very important, like this. First we represent the graphical representation for the given region of integration. And the second one is, from that region of integration, first calculate the limits of the inner integrations. That is, first with respect to y means it is inner integration. So first calculate the limits of the given integrals. and limits of the inner integrals of the function x by considering horizontal steps. Horizontal steps means we must denote the vertical steps and the horizontal steps for the limits for y and limits for x. For to calculate limits for x, we can consider the horizontal steps, and for to calculate the limits for y, we can consider the vertical steps. By change the variables, that is first with respect to x and second with respect to y. First calculate the limits for x and y in terms of the real numbers. By finding the new limits for x and y. Here the changed order is first with respect to x and second with respect to y, means first we calculate the limits for y in terms of the real numbers and x limits in terms of y, function of y. So finding those new limits, and we can calculate the double integration. So to change the order, first we calculate the original limits for x and y, and by changing, by using the graph representation, first with respect to, first calculate the limits for x by horizontal shifts and y in terms of the real numbers. This is working method to change the order of the integration. And the second one is change of variables. We can change directly to the variables. That means we change Cartesian coordinates to polar coordinates and polar coordinates to Cartesian also. So by using this method, that is, if x is in terms of uv and y in terms of uv, we can consider two functions, x equal to f of u comma v and y equal to g of u comma v. That means x and y are Cartesian coordinates and uv are general variables, another variables. So we are considering two transformations between these Cartesian coordinates and a new variables u and v. So these are the two relations between old variables xy with the new variables u and v of the coordinate system. To change the variables from xy to uv, so it is the double integration in terms of Cartesian coordinates, double integral or f of xy dx dy. We can change these variables to in terms of uv, that means du dv in terms of du dv. The region is same, double integral over r f of capital F of f small f and g. Small f g means here we are considering x as small f and y as the function g. We are substituting here in the place of x and y. We can get the function capital F of fg into modulus of the Jacobian. Here it is capital J means it is Jacobian. Du dv. It is the procedure to change the variables and to calculate the double integration. The Jacobian is here dou of xy by dou of uv. It is the process to find the Jacobian. Here we use by determinant dou x by dou u, dou x by dou v, the first row, and the second row dou y by dou u, dou y by dou v. By calculating the determinant of these four points, you can get the Jacobian, and we substitute this Jacobian in this here, which is modulus of Jacobian, the absolute value of Jacobian. So now here we can consider the Cartesian coordinates to polar coordinates. That means r theta. So xy are Cartesian coordinates, and here we can consider in terms of in the place of uv, the polar coordinates r theta. So the transformation is x equal to r cos theta and y equal to r sin theta. Here f of small f means uv, that is r cos theta, and g means here r sin theta. By considering these transformations, we can easily convert or change the Cartesian coordinates to polar coordinates, and then we can calculate the double integration. To calculate the Jacobian, here the Jacobian is, this is one, dou of xy by dou of r theta. That is Jacobian, dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. So by substituting all these values, cos theta minus r sin theta, r cos theta. So by expanding this determinant, we can get Jacobian is r. So r, by substituting the given formula, that is double integral over r f of xy is equal to dx dy equal to double integral over r, the same region r, capital F of, in the place of x we substitute r cos theta, and in the place of y we can substitute r sin theta. So capital F of r cos theta, r sin theta into the modulus of Jacobian. Here Jacobian is r, modulus of r is also the same r, because r is always positive value into dr d theta. In the polar coordinates, r is always positive because it is a distance value, so it is positive. So modulus of r is r. So to change the variables from Cartesian to polar coordinates, we use this formula. So integral double integral over r f of x by dx dy equal to double integral over r f of r cos theta r sin theta into r dr d theta. By using this, we can calculate and change the variables from Cartesian to polar coordinates, and we can calculate the double integration. Next one is another type of multiple integration, triple integration. As same as double integration, we can calculate triple integrals, means 3 times 3 integrations with respect to 3 different variables. If we take a function with 3 variables, x, y, z, then we can integrate that function with respect to x, with respect to y, and with respect to z in the same manner as double integrations. So here we can write dx, dy, dz, means dx is inner integration and dy means with respect to y middle integration, and z dz means it is outer integration. So if this is the order, means we must integrate first with respect to x, and second with respect to y, and third with respect to z. And similarly, these are the limits for x, y, and z. So x1 to x2 is the x limits, y1 to y2 is the y limits, z1 to z2 is the z limits. So by using these, we can easily calculate the triple integration, where the limits for z are z1, z2, which either constants or functions of x and y. So z limits are functions of x and y are constants, and the limits for y are functions of x or real numbers. This is the procedure to find multiple integration, the triple integrations, the evaluation process. So integration of x1 to x2, integration of y1 to y2, integration of z1 to z2, f of x by z, dz, dy, dx. So if it is the process, means first with respect to z, and second with respect to y, and third with respect to x. This is the basic order, and the inner integration limits are the first inner values, inner integration, and the second middle integration with respect to y means in the middle integration y values, y limits, and outer integration with respect to x means outer integration limits are in terms of x. So these are the x limits, y limits, z limits. So we can integrate with respect to z, with respect to y, and with respect to x. So it is the triple integration evaluation process. Thank you very much.